If you want to learn about debugging with Arduino, you are in the right place. This is part 2 of a 3-part seminar where I talk with embedded engineer Nino Vidovic from SEGGER. If you haven't checked out part 1, definitely check out part 1. It's about debugging in general. In today's video, what we're going to do is talk specifically about setting up the hardware and the software for debugging Arduino using Arduino IDE 2.0. Now, all of the software tools we talk about and all of the hardware tools are linked in the description below. So if you're wondering about any links we throw out, just check out the description here. All right, without further ado, here we go. Well, okay, I feel like maybe at this point we could shift and we could try.
Okay.
I say let's set some expectations for our practical application here, right? Like maybe things won't work as well as I want them to right now. Like, you know, like so I think it would be fun. You know, I imagine people might be listening to this, so they might not have the visuals right now. Up until now, I think folks would probably be fine. I think people will have hopefully garnered a lot of really useful information so far. Just listening, right? Not to say that, you know, people would be happy looking at our smiling faces too, you know, I'm sure.
Yeah, of course.
But anyway, but now maybe what I'll do is I will share my screen. I've got the Arduino IDE set up right now with, I'm using a Maker Wi-Fi 11010, I think is it. I've got it hooked up. I am using a J-Link Plus compact, which I bought, which I'm enjoying. I also have the EDU version.
Right.
I'm using I could have used either one. I just have to have the J-Link Plus compact hooked up.
Yeah. So one drawback of the J-Link EDU Mini is you get once a day an egg screen telling you you're using a J-Link EDU Mini, and please don't use it commercially.
Oh,
which you can click away on for the day. So this would be a drawback why it might maybe make sense. Like if this is very annoying to you, you can of course also.
All right. Okay. You know, I'm so glad you mentioned that, because what you're talking, and just so people listening might, so when you are developing, a little modal pop-up window will come up that basically says like, I understand that the license material, and you hit accept like that. I mean, you know, just like a window licensing, right?
Exactly.
No big deal. I've got a split screen set up, like I'm sure most developers do, right? Well, that modal window was popping up over here. I wasn't looking over there. I'm looking right here.
It's not working.
I'm just like, and it kept doing a timeout. And then I realized like, oh, there's this little window. I need to do something here. Eventually, you know, that clicked, but now I know why that is. Okay. All right.
So it's just to, you know, have some reminder on the users of this. Okay.
Oh yeah. Keep people on it. I get it.
Yeah. Right. And once you have the professional to probe, you of course don't get any next screens.
Right.
You just you have stuff to do, right? You don't want to press buttons.
All right, so let me set up this presentation. I am going to present a screen. Okay, so I think hopefully everybody can see that. The code isn't huge, but I guess, you know, and I do want to say that I just want to start this by saying that, Nino, if I understand correctly, SEGGER has an entire tool chain outside of different specific. So SEGGER has their own IDE for embedded development. They have their own tool chain for doing exactly what we're going to do here, like debugging and writing code and all that type of stuff.
Yes.
I hope that we'll get a chance to kind of like, you can kind of show that off, and that would be in a situation where you're not you're probably not working on an Arduino board, but you're working just bare metal,
right?
You know, just directly with an integrated circuit, not in the Arduino environment.
Yeah.
And so you're probably not super familiar with this Arduino IDE debugger tool. I'm probably just I'm assuming that a lot of the stuff looks similar. You know, you've got you know, a debug console and that type of stuff. So, so I've got this connected. And before we were talking about that JSON, you have to have some JSON information to connect the GDB server so that it gets called, and we're providing GDB server with the appropriate board information for our target device.
Yes.
And so that looks like here we've got this little JSON file, and and I don't know if the name matters or not, but I don't think it does. I'm going with the name that was provided
Right.
by the Arduino folks on
Yes.
their website, and they called it debug_custom, and it's just a
Yeah.
JSON file. And JSON is just a way of organizing data. It uses curly braces and key value pairs, comma separated, really common. If you're wondering what JSON is, you can just Google it. But it's a really simple file format. And basically, you're saying, okay, hey, what's the server type? We're saying, yep, we're using a JLink. What's the device? So this is going to help pair up the specific information for those protocols to the device. What is the interface here? I've got SWD, and I'm wondering, is SW is that the correct one for the maker? Is SW? I think SWD was right. Yeah.
I think Arduino only implements SWD because they use less pins, so they can route out more pins to the Arduino headers, right? So
Okay. Great.
yeah,
And then finally, we've got the server path here,
yeah,
which is literally this is where the GDB server is, where that application file is living on your
yeah.
host computer. So you're
So
going to go, before we mentioned, like, you got to download GDB server, you got to download it somewhere. Wherever that somewhere is, that file path is what needs to be here, because
yeah,
the IDE is literally going to go out and open up that program for you when you run this. And if it
yeah,
can't find where that program is, like, it's not going to work. You're going to get errors. You're like, hey, I can't find this. So it was a little bit tricky for me. Like, I don't know. You think it'd be easy, but sometimes you download stuff, you're not thinking about where you save it. You're just like, come on, download this thing. But
yeah,
so if you are in fact getting set up, remember where you download GDB
yeah.
server. That way you can just put that file path in
So
here.
as a side note, maybe here the standard guide from Arduino will show the setup guide for Windows. So it will also tell you where the JLink installer. So if you install our software on Windows, it will come with an installer. It will tell you where the path is. But if you're on Mac OS, you're getting a package. On Linux, the same. You have this Debian or whatever package that you have to unpack or install somewhere. So the paths might be different. So this in this case you're on Mac OS, I'm guessing. So this is
Yep.
the Mac OS variant path. So for Windows, it would be C something and then .exe on the end. For Linux, it's, I think, usually opt Segger and then the JLink version, and then also just like the macOS version because they're Unix based. And
All right.
so this is something to keep in mind. So depending on the host OS you're running on, this path might look differently. But yeah, as you said, simply try to remember where you installed it. Ideally, the installer tells you where. If not, the guides should provide the necessary
Gotcha.
information.
Okay. Well, that's good to know then, that it can be a pretty standard path then, it
Yeah,
sounds
yeah,
like. Okay,
yeah,
great. Okay, well, that's good to know. Okay. So that's really it. So that's really not too bad.
yeah,
And this debug custom, like, the information in here, you should be able to get from the Arduino website. And the only thing that's going to change based on is going to be your device if you're using a different device. And so you would have
yeah,
to update that debug JSON. But outside of that, it would just be like boilerplate code that you would just be like, oh, hey, I got to debug something. Let me go grab that file and paste it in here. And like, that's all I did was
yeah,
copy this from the Arduino website and paste it in here. It wasn't like I had to use any brain power. So, and that's a good thing. All right. So, and that is just a file. That debug custom is just a file living inside the same folder where your .eno file is, and so the way Arduino is set up, it's got an enclosing folder, and then inside that enclosing folder is a .eno file of the same name of that folder, and so this debug JSON's just in the folder there with it. Okay, so it's really not too bad once you understand what you got to do. It's not too confusing. Okay, so on the Arduino IDE, they have this sidebar. You've got your sketchbook folders, you got different the board manager libraries, but now IDE 2.0 has this debug section, and it's got this window over here. I'll kind of like open it up a little bit, and this is like, I don't know, the first time you jump into it, to me it's a little bit intimidating. I feel like there is kind of a lot of buttons. I feel
Yeah,
like Arduino has made the splash because they have less buttons. They've made things really easy, which I love. But with really easy, you kind of lose some of that. There's a trade off there, right?
yeah,
And so when I'm looking at this, I notice that there's like this space right here
yeah,
that talks about configurations. And if I understand correctly, this configuration file, once you have, what that's referring to is this debug custom, like what you basically have set up in this debug custom.json.
yeah,
And so when you first click this, there might be nothing, and you just kind of click add configuration. And that's when, it's gonna, I think it actually creates a JSON file for you. And I think
yeah.
right now it automatically names it as
Yeah, that's the
launch.json,
one. Yeah.
which currently, and again, like you mentioned, Arduino is kind of, this is like still newish, right, to
Hmm.
Arduino land. So I'm sure that, some of the specifics might change here, but JSON
Of
files aren't
course.
going away, so they'll be there.
Yeah,
But
that's going to be the way to
yeah,
configure this. Yeah.
so there was a bit in the documentation, there seems to be in the documentation versus reality, there seemed to be a little bit of a disconnect.
Yeah.
When does that ever happen? Geez. No.
Yeah, no, I never heard of that.
But so basically, you set up your configuration, and in this case, it automatically named it for me just to be Arduino. I'm looking in here, and I've got these buttons, and I've got these, I guess I'll call them little folders. Maybe it's like a hierarchy, right? And so here's just my program. It's just a simple blink sketch. I've got one global variable called LED pin. I've got set up with the common pin mode function, setting the mode of the pin as an output. And then in loop, I'm doing a digital write, setting the state high for that pin number. I do a delay and then a digital write, set the state low. Hello world of microcontrollers, right? So not too much going on here. At this point, what I would do is I would just there's this start debugging button right up here that I can press. And there's also the play button right here. So I think these are the exact same thing
Yeah.
for what I can gather. And
Yeah.
so I would just,
One difference, maybe just to mention, you will, I think, always be able to go into the debug settings on the left, like in this debug overview. This button is always available, but the button at the top that you press for debugging will be grayed out for boards that currently do not support the debug feature from the Arduino IDE itself. So this
uh,
button will be there, but it will be, I think, black or gray or whatever they normally think.
okay, great.
So
Okay.
here it's visible, and you can press it because the Arduino Maker Wi-Fi board from the board support package supports debugging. So just people are aware, if you have a board that's not supported, and it's, or this is graded out, one reason might be that the board is not supported yet.
Absolutely. That's a great point. Yeah. So a
Yeah,
lot of, like your just random Arduino Uno R3, that's going to be grayed out.
yeah,
And so that's a good visual indicator, like, oh, it doesn't look like this board's supported in the board support package. Okay. All
right.
right, great. Okay, interesting. All right. So we've been talking a lot about breakpoints. All right.
Yeah.
And I guess I was always under the impression that you always wanted to set a breakpoint when you're starting debugging, but maybe you don't have to. Like, I don't know. Okay, so here
Um,
actually I got two questions for. So when we set a breakpoint, basically the code is going to run up. Is it inclusive of that line of code, or it stops before that line of code gets executed with a
like
breakpoint?
the instruction before that line is executed and it stops at this line. It hasn't executed that line yet. So
Okay.
if you would do a step over that line, then it would in that moment execute that line.
Okay. So to set a breakpoint, so I'm on the left hand side of the bar here. There's this little space right here, and I can click, and it puts a little red dot. Now I noticed that
Yeah.
there's a little yellow marker there. I'm not sure what that yellow means.
Yeah, not sure yet as
Yeah,
well. Do you have a debug session running maybe?
I think yes, I do have a
Yeah,
debug
maybe you're
session.
stopped there. That's
Okay,
maybe
so that's
the
probably what it's.
yeah.
Okay, all right. Okay, so basically I've
If,
selected.
if you select the red rectangle, it's the stop button in
Okay.
the yeah, then it should, yeah, then it's gone. Then you have no connection to a target device, and now you have essentially the view that the user would have the first time
Okay.
sets
Gotcha.
this up, and doesn't have started the debug session yet.
All right. So if I wanted to start debugging this, I can go
Mhm.
ahead and hit the start debug
Yeah,
and let's see how it goes. Okay.
yeah, yeah. You
Resetting
see also
target.
the output from the GDB client, and I think also some part of our. Yeah, if you go in the GDB server, you will, for example, see the output from the J-Link GDB server, I believe. Yeah,
Okay.
this is, for example, the stuff that we print out. They will see the connect sequence, what it is doing. It's reading some registers and stuff like that.
Okay. Now, just to be clear, this is not the trace, right?
No,
This is a completely separate thing. It's just still a log from it's a
just a
log
log,
from
right?
GDB server. Okay.
Like what is it doing?
Okay. All right. And so what it's telling me right now is I've got breakpoint 1. So it's
Mhm.
telling me stuff. I've got this new console down here. So normally, you're used to, you've got your output and then you might have you've got your serial monitor, right? That kind of gives you information. But now we've got this additional tab at the bottom called a debug console. And this is going to be information that's provided by, this is being provided by GDB server. Is that correct? Like the information that gets shown here?
This information is actually from the Arduino IDE, but it's
Okay.
based on the information that the GDB server provides or the J-Link provides
Okay.
to the client, right?
Okay,
Yeah,
great. And then but there's another tab called GDB
yeah,
server, which is going to tell me what it's doing. Now, when I look at the output from GDB server,
yeah,
I don't know, what a lot of it means. It's saying, hey, it's reading a
yeah,
register. I'm sure for you, maybe a lot of these registers have, a lot of
yeah,
meaning. For me, they don't necessarily have a lot of meaning yet.
yeah. Usually, this is just the log that you send our support team if something goes wrong. So it's nothing to worry about. Usually, if it's something to worry about, we will tell you, and then you copy this and send us, right?
Okay, gotcha. That's awesome. All right, so right now, what's interesting is I've uploaded this program, this Blink program, and I've got this little external LED attached, but my LED is not blinking. The
Right,
LED is just dark right now, and that is because code execution has literally stopped before this digital write line.
right.
So I've set a breakpoint. I hit the debug. I hit the start debug. So when I come under threads, what I guess I'm curious, like, what is threads telling me then? What's threads
Um,
mean basically? I don't know.
I can only assume, to be honest, here,
Okay, no
because
worries.
threat means different things in different environments.
Gotcha.
Um, but usually, what I assume here is that the Arduino it has its bootloader running. The bootloader has also some kind of, at least some kind of scheduler running. Maybe not in full-sized RTOS, but at least a scheduler, and the scheduler can launch multiple threads. For example, I assume one of the threads will do the USB interfacing, so the regular UART stuff that you're used to from the upload button and stuff. This keeps working, and another thread might be load the sketch, load
Okay,
the file.
gotcha. All right.
So there's this thread that we now see is, as we also see it on the pair post on Breakpoint, is now this thread that is executing your sketch.
Okay, great.
Right.
All right. So if I were to go to, there's just a ton of stuff over here. So if I were to go
Yeah.
to call stack,
Yeah.
I've got some information here. It
Yeah.
looks like it's referring to two different files. So one is the name of the file that we're currently in, which I named blinkmaker at2.eno, and it's got a number next to it, 9. That looks like that's just referring to the line
Yeah.
number that
That's the
we're
line
at.
number. Yeah. Mm-hmm.
And then it's got a main.cpp file and it's saying line 53. So
Yeah.
it looks like I'm supposing a variable or a function name here, loop at, and
Yeah.
then,
Yeah. Let's maybe deep dive into call stacks. So call stack is your application on startup will allocate memory space in the RAM called stack. And stack is something where you can store local variables, for example, and if you're like would have an int I now that will be stored on stack, and then you can manipulate it and do calculations. And once you leave this function, this stack variable would be useless and could be reused on the next function call and stuff like that.
Mm-hmm. Yep.
Now, from this stack information, the way a microcontroller operates is when a function call happens, as I also mentioned earlier, was you have the CPU registers. And when you have function call, you have this input parameters, stuff like that. And you sometimes have to, or you have to save parts of the CPU registers to stack. So you can reuse all these registers inside the function to do calculations and stuff like that. And when you're finished, when you want to jump back, you usually load the jump back address from the stack, which you have temporarily saved somewhere, right? So with this information from the stack, the debugger can now read this RAM information and see where did we come from, right?
Okay.
And the top of stack is always where we're currently at. And as we see, we're at function loop. We can see this in the sketch.
Okay.
We are currently in line 9. And the function loop is located at memory address 000 something 2112 in hex. So this is the literal memory address of the function loop on the chip.
Oh, okay.
Right. And if you now, and you see this, there's another function below it, it's called main. And if you double click that one, it should open the main CPP file.
Yep.
And
okay. So here we are, main.cpp. Yep.
This is actually where we come from before the loop gets called. Because in Arduino world, your sketch consists of the function setup and loop and your static functions maybe that you add manually. But setup and loop are your main things that you fill with your stuff, right?
Mm-hmm.
And as you can see, if you scroll up a little bit, this is where we end up. As mentioned, usually the starting point of an embedded application or any application is, in many programming languages, is main.
Mm-hmm.
And this is where we start from with the Arduino. Before that, the whole bootloader stuff ran, where we don't have any debug information from, because it's an additional piece of software that's already running on the chip. But what we have now downloaded is this application, which starts with main. That's why we see, okay, and on the call stack, main, because this is where we came from. And main essentially calls all these functions that you're usually filling with your Arduino sketch in a specific order. You see there's init, then there's a little delay, then there's some USB functions called and initialized, and then you see there your setup, and you see a loop which calls the loop function. And then forever, it will stay here and execute your loop function. And as it looks like, also when it returns from the loop function, it will do some serial events stuff for the printing.
Right.
And and this is what you can now see in the call stack. And if you maybe return to the loop on the call stack, so you can from the call stack already, this is, let's say, some tiny trace, right? Because already now you see how your code has moved on in your execution to reach this point where you're at. You know in what line in the main CPP the loop function has been called, and now you know where your breakpoint is at in the loop function, right?
Okay.
And if you now, maybe we can go into some of the debug features, like step into. I think it's the third button.
Okay. Let's see. So, okay. So this is, all right. So that's continue. This is step over, and this is step into.
Yeah. If you press that.
Okay. And so this is going to go, well, let's just probably press it here. Step into. Okay.
And now we're in a different file.
Gotcha.
And a different file that you usually have never seen in Arduino world, because you never reach these places. But with a debugger you are.
Right.
So we're now in a library function called digital write, which you have called. And now you actually see the C code that's running inside this Arduino library that you're installing with your BSP and a board support package and stuff. Now you see on the call stack, that this call has been added because we have entered another function. Right? And
okay.
when we return from this function, it will be popped away from the call stack, and then the loop will be on the top again.
Okay.
So this is how this works.
All right. So if I understand, then main will always be at the bottom, right? Because main is the basement. Is that right? Like
in this type of application, yes.
Okay. So main's always going to be at the basement. Then we were in loop there. And now, so it's like we're diving deeper and deeper, and then we'll come back to loop, like you just said. If we were to exit this one or step out of this, we'd come back to loop. I want to say real quick, back when we were talking about the main.cpp, and so basically what Arduino does is they abstract away a lot of all of that other main stuff to make it easier for the end user. Like, hey, I just got to do setup, I just got to do loop. Like those are pretty reasonable concepts to understand, I feel like. And so that's where they've really done they've done a lot of work to try to make it easy for somebody. And what that means though is that again, you lose some stuff. So Arduino's doing stuff for you in your program. It's doing stuff for you before you ever get to your program code.
Right.
And that's the stuff you were talking about, like the init and some of this USB stuff. Okay,
exactly.
Great. And then literally the loop function is just running inside a for loop that just keeps going forever and ever and ever and ever and ever. So loops just getting called over and over. And okay, gotcha. All right. So back to this. So we're up at this digital write on the call stack here. Now, so I just want to, I want to look at these buttons right here again. So we've got, and if correct me if I'm wrong here, Nino, but these functions are going to be pretty similar regardless of what debugger I'm using. These are like just, okay.
This is the basics. Like every debugger will have this in some way or another.
All right. So I've got continue. The way I read continue, and this is where I'm a little confused. Does continue mean go to the next step, or does it mean go to the next breakpoint?
It just means go. It just means go, and the target will execute the application. Now, if you have set a breakpoint, it will run. It will maybe, depending where you set a breakpoint, it will reach that breakpoint and halt again. But if you have set a breakpoint, for example, in the init only, which is only called once, it will never reach that point again, and the application will now just run forever, and your LED will blink, and all is great.
Oh, okay.
Right? Gotcha. So continue is really, it just tells the microcontroller run.
Okay, gotcha. All right. Then I've got step over, and is step over saying go to the next step? Is that what that's saying then? Or
a little bit more than that. So we just tried to step into. So if you have a function call and you press step into, that means for the debugger, you're interested to see where this function is going. So it will jump to the function.
Okay.
But if you go to press step, instead would press step over. I mean, we can try this real quick. If you go to the loop back again to the sketch.
All right. So as in you want me to just step out?
No, in your files, in your file tab.
All right. Here's
on the left, I think. The most left file, the Blink MKR. That one. Yeah,
okay,
exactly.
Gotcha. Yep.
So if you now set a breakpoint on the next digital write.
Okay.
Yeah. By the way, there's also some standardized shortcuts. Sometimes they work or not. Setting breakpoints and removing breakpoints is most of the time F9 on the keyboard. So just so you and the users are aware, you don't always have to press buttons in the GUI. You can also use a keyboard. So you have both options, just to be aware of that. But I think for showing purposes, this is of course better with the mouse.
All right. Gotcha. Yeah. And just so I'm clear, it's going to set it where my cursor might be active.
Yes.
Okay. Exactly. So I just want to try this real quick. I'm just going to do. Let's see. Bam. F9. Oh, I love that. I love.
So it makes it quicker. Cool. So if you're a keyboard warrior, this is
all right. Yes.
Makes stuff happen, right?
And we should all aspire to be keyboard warriors, I feel.
Yeah.
Anyway. Okay. All right. So I've got this next breakpoint set, and I guess this is an interesting thing, Nino, that I wanted to ask. It sounds like we can dynamically set breakpoints. Like I can set a breakpoint at any point I want during this session.
Yeah. If the target is running, you set a breakpoint, the debugger sends a signal to the GDB server. The GDB server tells the J-Link, hey, I want a breakpoint at that address, and the J-Link tries to set it now as fast as possible, and it will set it, and when the program counter hits that address, it stops. If you're now your execution is stopped, you can now set breakpoints as many as you want. To keep interactions to the target device low, we will not do anything until you press go the next time, and then we will set all breakpoints before we say go on the actual target device.
Okay.
So if you've set 10 breakpoints, we will set all 10 breakpoints at once.
Okay. All right. I see what you're saying. All right. Minimally invasive then. Okay.
Exactly.
All right. Okay. So now I've set this next breakpoint.
Yeah, and then now you just continue. You just press continue.
Oh, just press continue.
Yeah.
Okay.
And now we expect that after a second, because we have a delay of 1 second there, we stop now at digital write again.
Okay.
So,
and all right, gotcha. And it highlights
now,
this line. All right.
And now if you press step over, you will see the difference.
Okay. So, all right. There's step over. I press step over.
Yeah. And now the LED should be, what is it now? Low is, I think, off.
Yeah,
right?
it's low. So the LED is off. Yep.
Yeah. So it should be off now, but we didn't jump into the function call. Instead, the debugger simply let the function run, and now automatically stopped after the function has executed.
Gotcha. Okay. So the program was stopped right after this delay. I stepped over digital write. Digital write still executes. Yeah. It's just, the debugger doesn't stop to like dive into it, right? It's let that entire function run, everything in that function run, because and just to be clear, so here's this whole function for digital write, it's doing stuff in here.
Yeah.
I guess what I'm going to do is I'm going to step over this. Okay. I want to get back to, let me see if I can get back to digital write again. Actually, I'll just press continue. Just that should get me to, run. Okay, or run. Yeah. All right. Yeah. So here I am at digital run or digital write. Right. If I go into or step into, that takes me to digital write. Now, does my step over, does that start to walk me through digital write?
For this specific line, it depends now on the line. This specific line does not do a function call. This is just some variable that is being set or checked. A variable is checked against some macro, right? So now step over or step into would do exactly the same thing.
Okay.
But if it's a function where we can jump to and show source code for, they would do different things.
Okay. So in this case, it doesn't look like, at least at first glance, like it's making any other function calls.
No, I don't think so.
Okay.
At least I didn't see any. No.
Yeah, I'm not seeing anything. Okay. All right. Well, that makes a lot of sense then. Okay. So I hit step over. Well, it looks like it does take me here. So AP port, and
it skips the if clause because it, of course, right, and then it's at the next instruction.
All right, and so I could, if I wanted, I could try to step into that and see what it does. Okay, but it's just kind of having me go on. All right,
and if you press step out, this is the next button to it. It will now jump out of this function to the last function call that was in the call stack.
Okay, so if I'll step out here. It takes me back to digital write, and now my LED is on. Yes. So the LED is turned on. Okay, great. All right, wow. Okay, so this is really pretty cool. Okay, so I feel like I have a, let's see, there's a restart button. Yeah. And I know we talked about, so we have a stop and then we have a restart.
Yeah.
And then we also have a reset device button. So I'm curious, like, I don't know. What are your thoughts here?
Actually, I didn't see that reset device button before. So if I had to guess, I'm guessing here. I didn't read the documentation. If in doubt, check the Arduino documentation. It will probably say more to this. But if I had to guess, the restart button will just do a software reset. Not the whole core is reset to its standard register settings and stuff like that. Instead, we just tell the debug logic, hey, please start from the beginning like last time. So you would still end up at main, do the initialization, tralala. reset device instead should, I'm guessing here, should do the same thing that a power on reset would do. So you have a clean slate, nothing has run yet, and this is the difference. So depending on the target device, this can be a different story. So I can't vouch for all chips that Arduino uses that it will always work the same way. But yeah, I'm assuming, like, if you in this case, if you press the reset device or reset a restart button, it should behave the same, which means it would stop at the breakpoint at digital right. I mean, you can give it a try.
Okay.
It should, in both cases, it should
All right.
end up at the same
we said
spot.
restart. All right. Let's see what happens here.
Yeah,
Yep,
we're here.
that's what it did. Okay.
Yeah.
So it basically enters me right back at pause down breakpoint.
Yeah.
Okay.
So the difference is essentially what happens to the chip. The one, so like the restart thing is just a command we send the chip and say, yo, please reset. The other one is a literal pin pull. So it triggers this JTAG, SWD, like it triggers a hardware thing. The one is a software thing, the other is a hardware thing.
Okay,
usually.
Gotcha. All right. And then I'm assuming the stop button is going to stop the debug session.
Yeah, the debug probe will at that point try to deinitialize anything that it might have touched from the debug registers, right? So it's in the same state as before, and then it just lets the chip go as it was before it started debugging.
Okay. Awesome. All right. This is great. Okay. So over on the left-hand side, so far we talked about threads. We talked about the call stack. I'm starting to get a feel for that. Seems to make a lot of sense to me. Now we've got this part over here on variables, and variables got a hierarchy in here. It's showing local, global, static, and then register. And so this is basically, this is going to be my window into different variables I might have set and different values inside the microcontroller that might be set. And so this is showing that I don't have any local variables, no memory in local. That makes sense. I go to global and whoa, a lot of options here. I'm kind of like, whew.
All you see here is whatever the Arduino software that you don't see is doing, right? So it's this whole stuff that happened before main or whatever main is setting. So all these variables are defined somewhere in the Arduino library. Of course, the debugger has used the compiler output and now knows all these symbols and is showing you there, right?
Right.
I'm not that deep in Arduino library stuff, so I'm assuming they don't like you to touch these variables because they have a purpose.
Right. Okay.
But worst case, you just reset your device and
gotcha. Okay. So these might be some flags that they set for different things, and it looks like they've got a ton of serial communication type.
For example, you also see the system core clock value variable there. This system core clock down there. It's
let me see. Oh, right here.
Yeah. And this is a typical variable in ARM Cortex M world, which is set during initialization, which tells the application later what clock speed is your chip running, which can be important depending on the application you're running. So you can use this variable at any time to know, okay, how fast is my chip?
Okay, fantastic. And so out of curiosity, the names here of these values are literally the variable names that are, is in the Arduino core that somebody might have written. That's what these are referencing. So these are referencing actual things that somebody wrote some code. It's that code that gets, that makes Arduino so user friendly in so many cases. They've done basically you kind of, one way to say it is you get all this for free because somebody's done a lot of the heavy lifting for you. Like, bam, here it is. You don't normally have to look at it, but now you can. Okay.
Yeah.
Interesting. Okay. Now, if I had my own local variable in here, I'm assuming then that I would be able to see it over here. Is that right?
Yeah. Let's give it a try. So just write an int I and then just count it up or something.
Okay. Let's see. Well, let's see. int I equals 0.
Right.
Let me just I plus plus. Well, that's going to get reset every time, but
exactly. But it doesn't matter for showing purposes.
Yep. Okay. So I'll go ahead and upload this code. Now it's showing me not connected, so I'm going to try, and this is something we kind of mentioned before. Sometimes this happens. Let me try.
Okay.
I think we'll get, I think
Yeah,
I'm,
don't use the upload button. Use the debug button. Then it will use the JLink interface instead.
oh,
That's
really?
yeah. Just use the bug download. The start debugging, and then it should work. Try that. Yeah, you see here there we go. Or did it
Okay.
work? Did it work? Did it
Let me
not
go to
work?
threads and see what
I'm
happens.
not sure.
Paused on breakpoint.
Awesome, but which one? Let's say
Um,
let's see the call stack.
well, it's, okay.
Okay, interesting. But it shows that it's at line 9. We might have. I'm not sure if the Arduino IDE rebuilds automatically, so you might have to hit the verify button first. So
Okay.
you stop just in case. Stop the debug session with the stop button.
Okay.
So everything is clean.
Yep.
Now try to rebuild the code with the verify button on the top left.
Okay.
And yeah, one thing maybe as a tip, so you get a little glimpse of what is happening in your Arduino IDE, and also gives you some debug information, is if you go to File, Preferences,
Okay. File. Okay. Yep. Preferences. Yep.
and then select Show verbose output during compile. Do you see that?
Yeah. Let's
And
see.
just
Show. Yep. Okay.
hit the
During compile.
compile. Yeah,
Yep.
and then
Okay.
set OK. And if you run this, wait a second.
Let me just verify that. There we go.
Yeah.
Okay.
Now you see all the funny compiler business happening in the background.
Yep.
And if you could scroll up, let's see if it's building with their compiling libraries. Go a little bit lower. Yeah, if you can, I need essentially I need to see the minus. If you could look for a -O somewhere there in this
Minus
whole.
O. Okay.
There it is. Okay, we have a -OG. Okay, so this is set when you have enabled the optimized code for debugging. This is now telling the compiler, hey, don't optimize as harshly as normally Arduino would, right? As we talked
Gotcha.
before, otherwise the debug information is missing. If you get a -OS there, the flag is either not set, or the board support package does not support, or the library does not support this mode yet, and it will optimize a lot of stuff away. So because
Okay.
one of the reasons, if you, for example, change your sketch and do some silly things like this, where variables are not really useful, or are not doing anything smart, like you being used in a function call or something, then compilers and with optimization will say, hey, this is useless for me, I will remove it.
Right. Yeah. Like, so if you just had a for loop that added numbers together and it
Right.
always does the exact same, you end up with the same number.
Yeah.
There's no
The
need for a
compiler will
for loop.
say, I already know it's 100. Then I
Yeah.
will just say
Okay.
it's 100. I will skip the loop, right? So
Yeah. And I think we talked about it before, but just so people can see it, it's under Sketch. So
yeah.
this is what we're talking about specifically, is under Sketch. You want to make sure that you've got optimized for debugging selected. Okay. All right, great. And then that basically sets a flag, that O flag, in this case,
Yeah.
OG,
Yeah.
the original flag, I guess. I don't know. And then
something like that. Yeah.
All right. Okay. All right. So,
So yeah, and now if you download it via the debug button, we should now end up at the right breakpoint, because we have recompiled the image. If not, then maybe the compiler has optimized our code away and we have to do something smarter. Let's
okay.
see.
All right. So let me try hitting the start debugging.
It worked. Okay, so it was simply it was loading the old application, the old sketch where these 2 lines were missing. In the old application, we had the breakpoint at line 9, and now the JLink was still setting it on the old address, if that makes sense.
All right.
Yeah. And now everything is correct. And if you open the locals window and the variables window, you should now see that I is there as a variable. No locals.
Well, so what I feel like, I guess where I'm feeling is that it's still working on this old code because I don't think it used the J-link to upload the new code to the board. That's what I'm thinking, at least. I could
Okay.
be wrong, but
Or set the breakpoint at the initialization. Int I is equals
okay. Let me
0.
try that.
Maybe the I'm not sure how the Arduino debugger works.
Okay.
It might
All
be
right.
that it says, okay, the variable is no longer used, so I will not show it in local scope anymore.
Okay. Yeah. All right. Let's see. All right. Good point.
So try that maybe. And if okay, no, it's still stopping at this.
Yeah, and I'm getting
Okay,
it's saying the
yeah, I see that.
DDD server. Okay.
Okay, try a power reset.
All right.
I don't
So
know.
yeah. So what I'm going to do, and this is, if you're debugging with
Yeah,
Arduino, this is just something you might happen to run into, is that
yeah,
the board disconnects, and it'll show you down here and not connect,
yeah,
that it's not connected. So in my case, if I can just press the reset button, usually that'll do it again. Let me try it. I might
yeah.
not. There we go. Let's see if that does it. If not, you can
Yeah. Just in
pull the
case,
board off.
make sure this sort of click stop debugging, so no
Oh, okay.
additional
Yeah. Let me do
no
that.
additional instance is running. Yeah.
Okay. All right. So it's still not showing up. So what I'm going to do, I'm just going to try, I'm going to hit that reset button one more time.
There it
Okay.
is.
So now it shows that it's connected. I can come up here. It's selected. Okay. And now I'll go ahead and click. All right. So we've got, let's see, we'll keep this breakpoint here, and I'll
Yeah.
go ahead and click start debugging.
Yeah.
And now let's see so now okay, here we go. So now we're back
Yeah,
in here.
it's skipping the line. I'm assuming that the compiler is just optimizing it away.
Is it? Okay. All right. All right.
Let's call it. Let's make it a volatile. Put it in front of it volatile int. Usually a compiler should not be allowed
Okay.
to optimize this
Let's
away.
try that again. Okay.
First stop the debug session and then recompile.
Okay. And so should we just try verifying again? What do you think? Like,
Yeah, of course. Yeah,
okay.
just in case, because I'm not
Yeah.
sure. It might be that the compiling sketch is done automatically when you hit debug. This is usually what IDEs and stuff like that does, because you want the new image in, right? But I'm not 100% sure if our Arduino
Okay.
IDE does that right now.
All right. So let me try the start debugging session, see what happens here.
Yeah, here we go. And now if you open variables local, we should hopefully, although it's down there, it says, here we go. Here we go. Okay, so right now we see some random number. That is because this is a stack variable, and the stack can have any value. Like it's RAM, and after reset, it can have any value. So this is any value at this point. Next reset, it can be something else. This is why it's important to initialize your local variables before using them. So if we now step, we should see that it's set to 0.
All right. Now, before we do the step, I just want to
Yeah.
say something that to me I find fascinating.
Yeah.
All right. And I just want to talk through this just to make sure I'm thinking this correctly.
Okay.
So what we did is we changed the code in the Arduino in this sketch. I added 2 lines of code, and just so I'm following, and maybe I did upload this, right? I did.
Yes.
I think I uploaded this the normal
You
route.
uploaded something, yes.
Yeah, I uploaded something the normal route. I want to say maybe it wasn't this because we didn't have the volatile.
Yeah.
But what you're saying though is I can make a change in my sketch.
Yeah.
I can, verify the code, make sure everything's running, but then I can hit the debug session, the debug start.
Yeah.
I'm sorry, start debugging.
Yeah.
And what's going to happen is the J-link is going to update the program on the target microcontroller.
Yes. Yeah.
Okay. That's pretty awesome. So I don't have to bother with that upload button if I've got my debug interface working. I can just hit that. So
start debug and it's downloaded. Yeah.
That's pretty handy. Okay. And so the way I've got, and it's a setting in the Arduino IDE, you can always verify before you upload. Like it's one step. So if you hit upload, it automatically verifies when upload. That's just a setting in the preferences. Right. And so that's usually, I rarely verify because I'm almost always uploading to check the code's running like I expect it to. What's important though, before you hit that start debug, you want to make sure you verify and then you hit start debug, because it's not going to verify the code necessarily when you click start debug.
Yeah.
Okay, cool. So, all right. So here we've got, there's just this, whatever was left over there. And now if I go to step over.
Yeah, or step into, in this case, again, it would not make a difference because we are not in a function call, right?
And now
and
it shows, 0. Hey, it's at 0. Okay,
Yeah.
now, because we're right before we increment I. So now if I do, well, this time I'll just do a step into it. Okay. Now it shows 1. So that's pretty cool. All right. I like that. And this is like now, and I can even change the value of I.
Now you can set it to, let's say, 50.
Okay, so I can click in here. I can set it to 50.
Yeah.
Does this let me do stupid things? Like, let's say that was a byte and I tried to write in something, bigger than a byte. Does that?
Depends on the debug software.
Gotcha.
I would assume that they might try to fit it in, but it will only program the byte. So only the bits will be set from the number that fit into a byte and the rest will be cut off.
Okay.
If that makes sense.
All right, great. Okay, so now I'm guessing the reason that LED pin is not showing up in global is because of the same issue that we had before, right? Like it's not seeing us.
I mean, it's being used, so but it's possible that the compiler is like, okay, I will not create a symbol for this, so because the debugger needs to have the name of the symbol. But if the compiler decided, I don't need to create a symbol here because I know what the number is, and he will just memorize the number and the memory address of the number, and he says, I don't care what it's named, it's 7, and it will just call the function with number 7. So if you step into, we can maybe then show. Then you should see different variables in local. Now, if you go to locals, you're still
Okay, oops, my bad there. All right, so let me close globals. All right, okay, so now
you see all kinds of things, right? And one of the variables is now the UL pin variable, and this is number 7.
I see. Okay, so I could probably find. Well, I guess I'm curious. Would I then be able to find UL pin inside my globals? Is that the reference it's making to? Maybe
no,
not.
the reference is simply not existent because the compiler now just memorized the number. Like it saved the number somewhere, but didn't create a symbol name for it because it says the symbol name is useless to me and just was memory space.
Okay, gotcha.
Right? This has a little bit to do with this compiler flag that we saw in the output, because the compiler flag Arduino used for this optimized for debugging stuff is, let's say, a trade-off between it's great for debugging but still has some optimization. For example, the default for our toolchain is usually to have just the default -O, which is just okay, generate an output without any optimization. And in this case, such local variables that for a smart compiler look useless, for you as the developer might be interesting still to know, so it would be available. But simply because how this library was built, this information is simply missing, so the debugger simply can't know it.
Okay.
Yeah.
All right. Okay.
But this is a trick. So if this stuff gets optimized away, still in the function call, you get a whole set of new variables, of course, and here it is again, right?
Okay. All right. This is really interesting. Okay, so I've got access to all these variables, and I've got access to these different registers.
Yeah. So these are the CPU registers we've talked about. So you see you have register 0, 1, 2, 3. So and these are all. So you see, for example, that R0 is the number 7. This is no coincidence because this is the first input parameter of the function. So as I mentioned, function calls follow a certain standard for the microcontroller, and this register has now this number which the function can now work with on assembly level.
Okay.
And all these values, so see from R0 to R3, they're initialized. From R4 on, I think it's random data. So this is just some numbers. But all these registers will now be used for calculations. So if you do a step and then we might see a change here.
Okay. I noticed I saw
Press it.
some of these
Yeah,
change.
see, so the values will change because the microcontroller will now execute multiple instructions and shift this data back and forth depending how it needs it. And when it's done, then you see at the end of the register list, you see some registers that are no longer called R, but there's SP. This is the stack pointer, so it shows the current stack location.
Okay.
LR would be the link register, which usually holds the address where it needs to jump back to when it hits the return. And the PC is the current address in memory where we are currently located at. So every time you press you step, this should increase or change if you jump somewhere else.
Okay. So SP the stack pointer.
Yeah.
The LR was the link register,
Link
and
register,
then
yeah.
the PC is that current point you're at. Okay.
Yep. For program counter is the
Program counter. Okay.
Yeah.
All right. Okay. Wow. Okay.
And the rest is some ARM special registers, which are I think they would be a bit complicated to explain now.
Yeah.
in
No
this
worries.
talk.
No worries. I've already learned more than I expected to learn here on the registers. I was like, this is pretty sweet. Okay. All right. Very neat. All right. So there's this. Let's see. There's this other one down here. Well, okay. So let's go into this breakpoint one.
Yeah. Okay.
So this breakpoint one is just going to show me, I'm assuming, where my other. It's just going to list where all my breakpoints are.
Yeah, and you can double click them. You can enable, disable them, and stuff like that.
Okay. Oh, double click would take me to where
it jumps there where it's set.
Okay. I see. All right. Interesting. Okay. Neat. All right. And I can disable, or I can just take them off like that. Okay.
Yeah. So if you want to disable them temporarily, like if you have breakpoints scattered all around your project, but you're currently looking only at one function, then you only have the one in the function enabled. But then later you want to check another code part and don't want to search the points again that are important to you, you can have a bookmark.
Okay, gotcha.
That you enable later, right?
All right. So this is a lot. So because I notice when I click here, it's the breakpoint still shows up. So I can set these like really important these key breakpoints in my code. But then when I'm trying to get to a specific little spot, I don't want to bother with all these other breakpoints. I can unselect those, and now it'll adjust appropriately. Okay.
Yeah.
I guess it looks
you can now add function breakpoint. I assume you can now add here a name of a function that you want to stop at, and it will set the breakpoint.
Interesting. All right. I'm not sure what. Oh, that looks like it toggles them on and off. Them, okay, so that's pretty neat. All right, and then, I just got rid of them all. Okay, so that's the button.
This was goodbye.
Remove all breakpoint. Maybe I should have gotten the helper text before I just don't. All right. Okay, disable all breakpoints and remove all breakpoints. Okay. All right. So that's the breakpoints. Now we've got some Cortex peripherals, Cortex registers. I don't know if this has any, bearing here. It doesn't look like there's much. Let's see.
Yeah, it's like you would have to supply a file here called SVW file, which is, I think, system. I think it should be SD. It's like a system description file or something.
Oh, okay, gotcha. All right.
And what it does is your chip has, of course, more than just the CPU registers, which the CPU is using for calculations, but you have your GPIO registers, you have your USB, you have your UARTs, you have stuff like that. There's always a base address and all these function registers, right? And essentially what this does is if you load up this SVD file, which is supplied by the silicon vendors usually, you can add it here to your project, and then it will show all these registers like you saw with the CPU registers. And you can, I assume it's not only for show, so it would read the current values of these registers, but on most debug debuggers, you can also manipulate these values. So if you want to test out quickly some GPIO or something, you could set it inside of this window instead of rewriting your code again and stuff like that.
Okay, gotcha. All right.
Yeah.
Well, that's really cool. All right. And then we've got Cortex registers.
Yeah, and this
So,
is, I think, just a summary of the Cortex peripherals and the variables registers window, because
okay,
you see their duplicate here and some additional registers. So yeah, I
gotcha.
would assume that it's just puts them together.
Okay. All right, cool. I feel like the last one we haven't talked about is the watch.
Yeah.
So this watch, this, if I understand correctly, this allows me to watch a specific variable. Is that right?
Yes,
Or
exactly. Depending on how it's implemented, it would only work on global variables. So you would have now to have a variable outside. I mean, you can try to add I. I'm not
all
sure
right.
if this will work. Let's try it and set the break. For now, what? Unable to.
See.
Okay, so it's not available. So yeah,
Okay.
because the thing is with local variables, you would need some kind of. You need to know the context in which you are currently at, and this might change during runtime. So once you leave the function, the watch window would show nothing useful
Okay.
because I was on the stack, but it's now doesn't have a purpose anymore.
Okay. So let's see. I'll just call it. So you know what? I'll make it 6 just to. Well,
Yeah.
3. Okay. There we go.
Yeah, and then you can
So
also increase it in the loop, so it does something. So it's not.
all right. So then we'll do
Yeah.
changing to 5 just to make it
Yeah.
interesting.
Yeah.
Oh, let me do 3. Okay. All right. So
So
then
now you should first need to verify it.
Yep.
So the
All
symbol
right.
is known to the debugger. And now you should be able to add it to the watch window. Or you can start the debug session, add it later, whatever.
So I could add it right now to the watch.
Already. If the symbol is known, this should work, yeah.
Changing.
Let's see.
I'm spelling that right.
Yeah, it should be spelled right. Yeah.
All right. Okay.
Okay, it can't currently read it because the target device is not connected. That is completely fine. But once we're connected and hit a breakpoint, for example, inside of the loop.
All right.
We're still connected. Okay, you would first need to stop the debug session from the last time. And then maybe set the breakpoint again in the loop.
Okay. I'll just do it.
For example, there, yeah.
Yeah. Okay.
And now we should be good. All right.
And there it is, changing 3. Okay, because I set it equal to 3.
You initialize this 3.
Okay.
And if you now hit run or continue step, whatever, it should increase. And
so I'll just hit continue. All right.
Yeah, and now it's busy and it's not showing any values.
Okay.
With other debuggers, for example, with Ozone, we can actually read these variables also on ARM while the target device is running. So we update this while the target is running. So this is something that other tools can do. Here you get it only when the target is stopped. But the main purpose of the watch window is to track essentially your custom set of variables that are interesting to you, because we just saw that in the globals window, it's a massive list of variables. Or if you have an array or struct or something, and you just are interested in a particular member of that struct, then you can just type that out here, and just the one value will be shown, and it's just cleaned up.
Yeah. Okay. Now, I feel like in VS Code, I'm able to add from local. Like I can add it to my watch list. I don't know if I can do that here.
That doesn't work here.
No,
I assume this is a feature that will come. Come.
Okay. All right. Cool. Okay, but that's pretty cool, because I know the watch list, to me, like you said, the watch list is pretty important, because it's like so much is going on, and just like cognitive overload there a little bit. And I'm, you're only interested in one thing. So, okay. Well, man, Nino, this has been like, okay. So I just feel like we have really, my expectations have been exceeded for the walkthrough of this.
Excellent.
You know what I mean? So this is just great. Well, I hope you enjoyed that as much as I did. I feel like I learned so much about just debugging in general, but also this setup for debugging with the Arduino IDE 2.0. Now, if you want to take it to the next level, which I have a feeling you do if you're watching this right now, then check out this video. We're going to talk about debugging Arduino using Embedded Studio.